All right, today we're going to work on lesson 4.3, which is slope-intercept form. We're actually going to begin by working on determining if a given equation is a linear equation. And then once we know that it's a linear equation, being able to write it in slope-intercept form and then identify obviously the slope and the intercept and use those to do some graphs. Okay, so identifying whether an equation is linear. All right, there's a few things we have to look for. So an equation, first of all, it's got to be written in simplest form before we make that decision. And I'll show you a little bit about that in a second. But number one, no, there are no variables raised to a power other than one. Okay, so y equals 3x squared, that's not a linear equation because x is raised to the second power. No variable appears in an exponent. So y equals 4 to the x power can't have a variable as an exponent. That's not going to be a linear equation. No variable appears in the denominator. Okay, so if I had y equals 4 over x plus 5, the fact that this x is in a denominator eliminates it as being a linear equation. And last of all, you can have no variables multiplied together. So if I had like y equals x times, 5 equals x times y, the product of x and y, this will not be a linear equation. So those are the things that we look for that would eliminate an equation from being linear. The second thing is you got to make sure it's in simplest form. All right. An equation is in simplest form. Number one, when the y variable is isolated on one side of the equation. And then second of all, the expression that's on the other side of the equation is in simplest form. That is, we've combined like terms, we've distributed, we've made it as simple as we can with as few terms as we can. So let me give you an example of why it's important that we have it in simplest form. Let's say I gave you this equation and asked you, is it linear or not linear? You might right away say, well, you know what? I see an x squared. This is not a linear equation. But upon further examination to the trained eye, we know that this is not in simplest form yet. We know what we could do to isolate y is subtract x squared from both sides. When I do that, these x squareds are both eliminated, and I'm left with y equals 2x plus 10. And yes, this is a linear equation. All right. So because I solved it for y and got the other side simplified, I can see now that there aren't in the end any variables to the second power. So therefore, it is a linear equation. So you have to simplify before you can make the final conclusion. You're going to get some problems that go like this tonight. Determine whether the equation is a linear equation or not. This first example, y equals x cubed, obviously x to the third power, that's a no-no, right? I'm going to list, I guess I should have done this prior to, I'm going to list what we're looking for. No variable raised to a power other than one, that would eliminate it. No variable appears in an exponent. No variable appears in a denominator, and no variables are multiplied together. That's the list you got on your first page. So going back to this first one here, y equals x cubed, because x is raised to the third power, not linear. Y equals x squared minus 5, x is raised to the second power, not considered a linear equation. This one, y equals negative 9 times x. Okay, well, my variables are both to the first power. I don't have a variable in the denominator. I don't have a number raised to a variable power. They're not multiplied together. Yep, that's linear. D, same thing. Variables are both to the first power. There's no exponent no variable as an exponent, nothing in the denominators, not multiplied together. Yes, that's linear. And that's all we're looking for. Go through our checklist, make sure it meets the requirements. Okay, another page of this, I'm going to list again what we're looking for over here on the right. If I go through this, now there looks like a lot of stuff. There's an X and a Y and another X. Okay, a couple of numbers, but none of these variables are raised to a power other than one. The variables aren't multiplied together. Okay, we don't have a number raised to a variable power. There's no variables in denominators. If I was to go through and simplify this, solve it for y, it would be linear. I would only have an x and a number on the other side. Okay, b, right away I see x in the denominator of a fraction. That's a no-no. C, 8x equals negative 9. Now you may say, well, I don't see x's and y's. You don't have to have both x's and y's. You can have an x or a y. But if you go through your list, x is to the first power. There's no x. There's no variable in the denominator. There's not variables multiplied together, and there's no variable as an exponent. So yeah, this one's linear. This last one, you might see a bunch of decimals and think that's a problem. It is not. It's all about variables. They're both to the first power. Okay. There's no variable in the denominator. There's no variable as an exponent. There's not variables multiplied together. So even though there's decimals and such, that doesn't matter. That's a linear equation. So that's the first type of question you're going to get. Second type of question is going to be this: what if I gave you the information as a list of ordered pairs? So what we're saying here is a function is linear if and only if a constant change in the input, which is the x value, yields a constant change in the output, which is y. So if we're given ordered pairs and asked to identify if it's a linear equation based on the ordered pairs they give us, what we got to do is we got to look at all consecutive x values and see that they have a common difference. If they do, then their y values, corresponding y's, they also have to have the same common difference. Okay. So let's take a look at this. Let's say a function is defined by these ordered pairs, these four ordered pairs. Is this a linear equation without graphing it? Now we could graph it accurately and look at it and make that determination, but what we're going to do is do it a little differently. I'm going to put it in a little table like this. So as -5 was an input, 3 was an output. -4 was an input, 0 is an output. -3 is an input, -3 is an output. -2 is an input, -2 is an output. Okay. Now, if I look at my x's, they're going up by 1. So up by 1. Now, what happened over here with the y? Well, when this y change was, I subtracted 3, went from 3 to 0. On the x's, I went up by 1 again. So what happened on the y's should be the same thing. It is. I went down by 3. On the x's, I went up by 1. But on the y's now, I added 1. So this change is not reflected the whole way through. I'm changing at a constant rate on the left, but I'm not on this right side. Therefore, this is not a linear equation. Okay, that's what you're looking for. Constant change should reveal constant change. All right. Now, you're going to have a table like this, or you're going to have a page like this in homework. All right, here's my ordered pairs that they're giving me. They didn't give me a table. I'm just going to look at it this way. Is it a constant change? Well, my x's go from 5 to 7 to 9 to 11. So they're going up by 2, up by 2, up by 2. That means that these should be changing at the constant rate. So -4 to -8 is -4. I should be subtracting 4 again and get -12, but I didn't. I got -13. That immediately tells you it's not linear. My x's changed at a constant, but my y's did not. And you'll notice that the constant was up by 2 each time. That's we can do it up by 2s, up by 1s, up by 3s, as long as it's a constant change. Let's look here. Our x's go from 2 to 6 to 10 to 14. So that's up 4, up 4, up 4. That means our y's should change constantly too. I went from -3 to -3, so I added 0. -3 to -3, I added 0. -3 to -3, I added 0. So that is a linear group of ordered pairs. If I graphed them, they'd all be on the same line. Okay, down here. Now I got a chart. So from -1 to 0 is a change of 1. 0 to 1 is adding 1. 1 to 2 is adding 1. So my x's are changing at a constant rate. What are the y's doing? Well, 3 to -2 is -5. -2 minus 5 is -7. -7 minus 5 is -12. That's constant. That's linear. Here, okay, -4 to -3 is +1. -3 to -2 +1. -2 to -1 +1. What's going on here? +5, +5, -4. No good. That's not linear because the rates didn't change constantly throughout. Okay, so that's a little bit of how you identify without a graph or an equation, just by looking at it this way. Okay, slope-intercept form. So slope-intercept form of a linear equation looks like this. Oopsie, where's it at? There. Y equals mx plus b. So the y and the x are always in the problem. The m and the b are what we're looking at. The m represents some number, and the b represents a number. Now, the number that is here for the m, the one that's being multiplied by the x, that's always the slope of our line. The b, the number added to that, is the y-intercept. So this is why they call it slope-intercept. If I can write my equation so it's y equals mx plus b, the number times x is the slope, the number added to it's the y-intercept. Really easy to graph then, okay? So if I gave you y equals 3x plus 5, actually I'm going to give you three equations. Y equals 3x plus 5. Is this written in slope-intercept form? Yeah, it's solved for y, okay? What's the slope? Well, it's the number times x, it's 3. What's the y-intercept? Well, it's the number afterwards, plus 5. So the y-intercept is 5. Easy to graph. Second one, is this one solved for y? Yep, y is over here by itself. All right, so identify the slope. The slope is a number being multiplied by x. That's negative 2/3. The y-intercept's the number added to that. That's 4. Last one, is it solved for y? Yeah, it's solved for y. The number multiplied by x is 3/5. That's my slope. The number that's attached to that, minus 7, means my y-intercept is at negative 7. So y equals mx plus b is a form we like to use a lot. Okay. All right. Now, the second piece of this, what happens when the equation is not in slope-intercept form? Well, it's a lot easier to graph if we rewrite it in that form before we go about graphing it. Okay. So an equation can be rewritten in slope-intercept form simply by solving it for y. All right, so let's take a look at this equation. Let's write the equation negative 22x plus 8y equals 4 in slope-intercept form. Okay, holy cow, where'd that come from? All right, so let's go ahead and take this equation, which is not that one. Let's solve this one for y, put it in slope-intercept form. All right, so I want to solve for y. I want to isolate my negative 4y. So the first thing I got to do is subtract 16x from both sides. Okay, on the left side, 16x minus 16x is 0. On the right side, these are not like terms, so I can't put them together. So what I'm going to have is negative 4y equals, and I'm going to put the negative 16x first, minus 56. Okay, I like to have the x term first and the constant last. So I'm going to write it like this. All right, now I want to solve for y. So I want to get the coefficient of y to become positive 1. To do that, I'm going to divide each side by negative 4. Now notice I'm dividing both of these two by negative 4. It's not one or the other, it's this side. So this side gets divided by negative 4. Over here on the left, negative 4 cancels negative 4, gives you a positive 1. What we're going to do on the right is separate these two into two fractions, each divided by negative 4. So I'm going to take negative 16x and divide it by negative 4. And I'm going to take the negative 56 and divide it by negative 4. Okay, so negative 16 divided by negative 4 is 4x. Okay, and the negative 56 divided by negative 4 is positive 14. Okay, so it's now solved for y, and I know the slope is 4 and the y-intercept is 14. All right, so we want to practice this now. So let's do another one. Negative 6x plus 3y equals 9. Okay, our what it asks us to do is find the slope and the y-intercept, put them in simplest form. So we need to take this, solve it for y. How do we do it? Isolate 3y first by adding 6x. These are not like terms, right? 6x and negative 9 aren't like terms. So I'm just going to write it as 6x minus 9. Over here, this negative 6x and positive cancel. Now I want to make the coefficient of y become a 1. So I'm going to divide both sides by 3. Dividing this side by 3 means each one of these gets divided by 3. So I get 6x divided by 3 minus 9 divided by 3. Okay, simplifying each of these, I'm going to get y equals 2x minus 3. So my slope is 2. My y-intercept is negative 3. Okay, so that's working that process, being able to solve an equation for y. Another one here. So I got 7x minus 2y equals negative 10. Right, I want to isolate my negative 2y. I guess I'll say it that way. I want to isolate the y term, so I'm going to have to subtract 7x. 7x minus 7x, 0. Not like terms, so I'm going to put them together or list them next to each other. So negative 2y equals negative 7x minus 10. Okay, now I want to make the coefficient of the y become positive 1. I'm going to divide each side by negative 2. Everything gets divided by negative 2. I'm going to rewrite it now. These are going to cancel. That's why we did it, is to get this to be a positive 1y. And then each one of these get divided by negative 2. So I put negative 7x divided by negative 2. And then I wrote minus 10 divided by negative 2. That's the minus sign that I wrote right there. I could have wrote plus negative 10 over negative 2. I'm going to get the same result. All right, negative 7x over negative 2 is really just 7 over 2 times x. Okay, that x that's in the numerator can be written next to the fraction with the fraction as a coefficient. That's my slope. And then I get minus 10 divided by negative 2 is negative 5. So in the end, I'm going to get 7 halves x plus 5. Minus a negative is plus. All right, so I know my slope is 7 halves, and I know my y-intercept, sorry about that, should be positive 5, not negative 5. Okay, a couple more to look at. putting it all together here. All right, now we're going to be given an equation. We're going to ask to find its slope and y-intercept, and then graph it. Use that information to graph. So put it all together. So take our given equation and solve it for y. Put it in slope-intercept form. Subtract 4x. Okay, divide both sides by positive 3. That cancels. Divide each one of these by 3 and simplify. I get negative 4/3 minus 1. So slope is negative 4/3, y-intercept is negative 1. Use this to graph. Well, we're crossing the y-axis at negative 1 right there. My slope is negative 4/3, so I'm going to go a rise of 4 and to the left 3. I got to go up and to the left to make the slope negative, correct? And there's another point that's on my line, and then just connect them. And there's the graph of this equation, and the original equation is equal to this one when it's written in slope-intercept form. Okie dokie. All right, let's do another one here. Here's the given equation. Find the slope to y-intercept, then graph it. All right, so here's the equation. Solve it for y. You guys are going to get really good at this. Subtract 5x. 4y equals negative 5x plus 8. Divide everything by 4 on both sides. That cancels here. Becomes negative 5x over 4 plus 8 over 4. Each one of these two get divided by 4. I get negative 5/4 x plus 2. Oh, slope's negative 5/4. Y-intercept is 2. Go over here and graph it. So I want to go on the y-axis to positive 2. Now I'm going to go a rise of 5 and a run of negative 4. Up 5 to the left 4. Remember, this is a negative slope. And it's going to go down like this. All right. So that's everything. So that's a look at some slope-intercept concepts, being able to identify a linear equation based on either a given equation or even a list of possible ordered pairs, and then getting into understanding slope-intercept form and being able to convert to it. All right. So there's a lot there. Hopefully you took some notes, wrote some things down. The homework's on Alex, and it follows those examples that I gave you pretty darn close. All right. I'll let you get at it.